something extraordinary has re-entered the crosshairs of science. After months of silence, new observations have thrust three I/ATLAS back into the global spotlight. Not through rumors, but through a hard chain of measurements that refuse to obey the laws of known physics. Post-perihelion images captured by telescopes around the world revealed a compact, sharply defined nucleus, where a vast tail of gas and dust should have streamed. The object, expected to fade harmlessly into the darkness beyond Mars, instead showed continuing acceleration, measurable, deliberate, and utterly unexplained. Inside observatories from Hawaii to Chile, astronomers stared at screens that made no sense. The trajectory of Atlas wasn't just changing, it was evolving, shifting sideways as if guided by invisible hands. Non-gravitational acceleration had been seen before in comets, but never this controlled, never this symmetrical. The plumes that should have betrayed violent jets were absent, and the infrared signatures were too clean to hide any debris. Somewhere in the data, something was pushing, and nothing visible was doing the pushing. The discovery rippled across research networks. Equations failed, simulations broke, and sleepless scientists recalculated the math of celestial mechanics from scratch. Each new dataset seemed to whisper the same sentence: "You're missing something fundamental." To some, the anomaly was exhilarating. To others, it was terrifying. A comet was supposed to obey gravity, not argue with it. But Atlas, the third interstellar visitor in recorded history, appeared to be making its own rules. And as telescopes struggled to track it, a quieter story began to surface behind the spreadsheets. An unsettling story about withheld images, political intervention, and a sudden change in who controlled the narrative. On November 4th, 2025, amid a paralyzing government shutdown, but Atlas, the third interstellar visitor in recorded history, appeared to be making its own rules. NASA Administrator Sean Duffy was out. His replacement, billionaire pilot and entrepreneur Jared Isaacman. No explanation, no context, just a 23-word post that arrived precisely when scientists around the world had been counting down to the public release of the long-delayed JWST data on 3I/ATLAS. At first, the media treated it like any other political shakeup, an impulsive move, a distraction from the budget crisis. But inside NASA, the timing set off alarms. Servers holding JWST's ATLAS imagery were suddenly marked under review. Engineers found their access credentials suspended. Department leads received ambiguous internal memos citing data management restructuring. Private Slack groups used by senior astronomers for data sharing vanished overnight. One systems engineer later described it succinctly: "It felt like someone pulled the plug on the truth." The shift rippled through every major science hub in the US. The Goddard Space Flight Center canceled scheduled briefings. The Space Telescope Science Institute issued an internal lockdown on public data channels. Teams at the Jet Propulsion Laboratory were ordered to pause all outbound correspondence related to JWST datasets until further notice. For a community built on collaboration, the silence was deafening. Within hours, speculation swarmed. Was the firing related to ATLAS, or had it merely provided a convenient excuse to stop something bigger from leaking? Some argued that Trump wanted a loyalist. Isaacman was a private space entrepreneur who had led civilian missions with SpaceX and had close ties to the administration, but others suspected coordination at a higher level. Duffy, known for his commitment to transparency, had reportedly opposed delaying JWST's ATLAS findings. If so, the timing wasn't just suspicious, it was strategic. Across the scientific world, reactions polarized. Traditionalists urged patience, claiming this was just bureaucratic chaos. But independent researchers called it what it looked like: a blackout. Even the European Space Agency issued a statement urging continued international collaboration in the spirit of open science. A diplomatic jab disguised as reassurance. In private chat rooms, some scientists admitted an unspoken fear that perhaps the data itself had forced the hand of politics. What if JWST had captured something not just unprecedented, but paradigm-breaking? Something a government would hesitate to release unfiltered. As Washington descended into partisan squabbles, scientists turned their eyes elsewhere. The United States might be silent, but another superpower was about to speak, and with perfect timing. The breakthrough didn't come from Houston, Pasadena, or Cape Canaveral. It came from Beijing. On October 3, 2025, the China National Space Administration quietly uploaded a dataset to its public server. 36 high-resolution images of 3 ICOS Atlas taken by the Tianwen-1 Mars orbiter at a distance of 28.96 million kilometers. The upload appeared with no fanfare, just a timestamp, a short press note, and a technical header written in Mandarin. Yet within minutes, scientists around the world realized what it meant. China had broken the silence. The data was unprecedented. The high-RIC camera aboard Tianwen-1, equipped with a 38.7 centimeter mirror and cutting-edge sensors, captured a sight that seemed to defy logic. Atlas wasn't the diffuse, chaotic cloud that comets become after perihelion. It was compact, luminous, and symmetrical, a glowing orb with a faintly defined halo that refused to disperse. The coma measured only a few thousand kilometers in diameter, unnaturally small for an object that had just endured solar heating. And then came the rhythm. The Chinese analysts noticed a subtle flicker in Atlas's brightness, steady, consistent, pulsing every few seconds with mathematical precision. When plotted, the light curve resembled a repeating waveform, clean enough to mimic the heartbeat of a machine. It wasn't random, it wasn't natural noise. The pulses were too exact, too intentional. The Chinese release included not just still frames, but a 30-second video sequence, stitched together from the raw telemetry feed, showing Atlas drifting through the Martian sky. The object shimmered faintly against the backdrop of stars, moving smoothly, almost deliberately, maintaining its orientation as if stabilized. For scientists accustomed to chaotic, tumbling comets, it was breathtaking. For the political world, it was provocative. The West took notice. In Washington, the images spread across intelligence channels before the public even saw them. At ESA headquarters in Paris, researchers quietly verified the data and confirmed its authenticity. No artifacting, no software trickery. The Chinese dataset was clean. A few hours later, the images hit international news feeds, accompanied by headlines like, "China reveals stunning new footage of interstellar visitor." It wasn't just a scientific coup, it was a diplomatic masterstroke. China had outmaneuvered the United States by stepping into the silence left by the shutdown. The release was methodical, neutral in tone, yet devastatingly effective. It forced every other agency to react, and it reclaimed scientific credibility on a global stage long dominated by the West. In one subtle act, Beijing had transformed ATLAS from a mystery into a symbol of scientific rivalry. The data's implications were as clear as they were disturbing. Atlas was still active, still changing, and its trajectory, once comfortably outbound, was now bending inward. The object wasn't retreating from our solar system, it was turning back toward it. The United States couldn't remain silent forever. Pressure mounted with every passing week of the shutdown. Behind closed doors, NASA scientists, unable to release their findings officially, began leaking hints to trusted colleagues overseas. In encrypted forums and late-night emails, one phrase recurred, "Loeb was right." Then the dam cracked. A congresswoman, young, articulate, and a rising star on the House Science Committee, posted a brief message on social media that detonated across the world. Had a good conversation with NASA about Atlas. When the government reopens, they'll release the data. Dr. Avi Loeb was right about the anomalous tail. NASA saw it too. 3 sentences, that was all it took. Within an hour, #Atlas trended worldwide. Journalists flooded her office with requests. Her staff refused interviews, but the message spoke for itself. NASA had data confirming Loeb's early claims of anomalous acceleration and an unnatural tail, and that data was being withheld. The public reaction was instant. Talk shows debated whether the government was covering up the discovery of alien technology or simply managing a scientific anomaly. News anchors invited physicists and politicians alike to weigh in. Some dismissed the story as political grandstanding, others saw it as the first crack in a dam holding back something far greater. Meanwhile, Avi Loeb responded the only way he knew how, with calm defiance. On his personal blog, he wrote, "Science is not the property of nations. It is the dialogue of curiosity under a shared sky." The post went viral, earning millions of views in hours. Scientists worldwide echoed his words, signing open letters demanding data transparency. NASA's silence only amplified suspicion. By week's end, several whistleblowers had come forward anonymously, confirming what many feared. The JWST had captured high-fidelity imagery of ATLAS displaying patterns inconsistent with known natural processes. One leaked memo described a compact body exhibiting coherent outgassing behavior suggestive of vector stabilization. In simpler terms, it was steering. For NASA, the situation had spiraled beyond containment. The story was no longer about astronomy. It was about control, transparency, and the collision between politics and discovery. And as global media devoured every detail, Atlas itself kept moving. Silent, indifferent, its faint green shimmer now a nightly reminder that the universe, not Washington, decides what humanity is ready to know. When the numbers finally arrived, they told a story that broke every textbook open. If Atlas's acceleration were caused by jets of gas, it should have expelled at least 13% of its total mass during its solar pass. Billions of tons of material. The ejected dust and vapor would have formed a spectacular tail visible even through amateur telescopes. Yet photographs showed almost nothing. A tight core, a faint mist, and clear space beyond. It was the kind of discrepancy that leaves scientists staring at their own equations in disbelief. Momentum must be conserved. Propulsion requires fuel. But here was thrust without thrust, motion without evidence. Astrophysicists called it the 5 billion ton paradox. Some proposed that invisible gases, perhaps exotic volatiles, were escaping in bursts too brief for instruments to catch. Others whispered of mechanisms that needed no physical exhaust at all. In conference halls, voices lowered. The data did not just challenge cometary science, it challenged physics itself. If the numbers were right, something was propelling ATLAS, and that something remained hidden. Spectroscopy made matters worse. When researchers decomposed the light from ATLAS's coma, they found chemical fingerprints that defied every natural origin story. Nickel dominated the spectrum, while iron, the common twin element in almost every cosmic body, was nearly absent. The carbon monoxide to water ratio was off the charts, suggesting not thermal evaporation, but something resembling chemical engineering. Some of the spectral lines even matched compounds such as nickel tetracarbonyl, a substance known on Earth only as an industrial byproduct of metal purification. For an interstellar traveler, that finding bordered on blasphemy. The data didn't just surprise, it destabilized decades of astrophysical assumptions. Comets are supposed to be time capsules of creation, pristine remnants of early solar chemistry. But Atlas was something else. The ratios of carbon monoxide, methane, and nitrogen-bearing volatiles suggested extreme processing, as if its materials had been refined in an environment entirely foreign to natural physics, perhaps in the magnetic disk of a dying star, or the metal-rich debris field of a collapsed system. Every model required temperatures so cold that only nickel compounds could remain solid while iron was stripped away. But even that exotic theory couldn't explain why its surface behaved as though it had been polished. Polarimetric data added another twist. The way light reflected off Atlas didn't resemble fine cosmic dust. It behaved like a mesh of metallic foam, a structure with microscopic pores arranged in regular patterns. Computer simulations showed that only materials with internal order, something akin to crystalline lattices or woven composites, could replicate the observed scattering. That finding ignited the first public argument at the International Astronomical Union in decades. Was Atlas a geological miracle or an engineered relic? Within hours, news anchors were repeating the phrase, impossible chemistry. Some scientists urged restraint, but others couldn't ignore the parallels between the spectra and compounds forged in human laboratories. Either this thing was built, one astronomer said quietly, or nature just invented metallurgy before we did. And for the first time, silence filled the room after the statement. Not disbelief, but the quiet of minds realizing that they had run out of explanations. By late autumn, the debate hardened into 3 possibilities, each improbable, yet each supported by inconvenient fragments of truth. The first treated Atlas as an extreme comet, a cosmic outlier so strange it would force the rewriting of cometary science. Maybe its ices sublimated through microscopic vents distributed perfectly across the surface, balancing each jet's recoil until the object seemed guided by design. The symmetry could be coincidence. After all, nature occasionally balances chaos with beauty. Yet even the defenders of this theory admitted the odds were microscopic. We're talking about dice that come up the same number 1,000 times in a row, said one researcher. The second theory ventured into unfamiliar territory, non-thermal propulsion. In this vision, ATLAS was a natural reactor, a frozen dynamo of magnetized minerals and trapped electrical charges that interacted with the solar wind. As it rotated, these internal fields could generate bursts of force, microthrusts invisible to the eye but powerful enough to steer. Computer models from MIT showed that under rare conditions, a body with conductive veins of nickel and carbon could oscillate in solar radiation like a living circuit. The term magnetic sail began circulating in research papers, followed by heated debate about whether nature could really construct such a thing accidentally. The third hypothesis was whispered more than spoken: artificial origin. Not aliens in the cinematic sense, but technology. An artifact adrift, built for reasons we can't yet guess. The evidence was circumstantial but cumulative. Nickel dominance without iron, a mathematically precise trajectory, and symmetric gas emission that looked too controlled to be geological. Could Atlas be a derelict probe, a fragment of a star-faring civilization's experiment, or a machine built long before Earth cooled? To claim that was to risk ridicule, but to deny it outright was to ignore the data. Scientists spoke with the caution of those staring into history. Proof would come only through observation. That's why the December campaign mattered. For the first time in human existence, telescopes weren't just studying a comet. They were preparing to interrogate the possibility of design. 3 hypotheses, 3 mirrors of our own curiosity, each, in its way, reshaped how humanity saw itself, either as cosmic coincidence or as neighbors in a universe of makers. When the International Consortium compiled its findings, the final report on 3I/ATLAS didn't read like a scientific paper. It read like a mystery novel written by the cosmos itself. Everything about the object was wrong, contradictory, or both. Its orbit was retrograde, moving opposite the planets, but astonishingly aligned with the ecliptic plane, as though deliberately inserted to mimic our solar geometry. Such precision was statistically absurd, a cosmic bullseye in an infinite void. Instead of shedding material away from the sun like every other comet, ATLAS did the opposite. It emitted a thin jet directly toward it. Radiation pressure should have scattered that plume like mist in a storm. Instead, it held formation, tight and symmetrical. The jet even appeared pulsed, timed bursts that repeated every 21 minutes, suggesting some hidden cycle of control. Observers from Chile and Japan confirmed the pattern independently, eliminating the possibility of error. Then came the enigma of its speed and strength. Atlas traveled too fast for something so dense, yet too stable for something so fragile. Its calculated tensile resilience matched that of solid metal rather than frozen gas. As it neared Jupiter, it skimmed behind the gas giant's magnetic field, vanishing briefly from telescopic view. An evasive maneuver, some said, though no one dared use that word in print. Spectral readings showed an overabundance of nickel, almost no iron, and trace elements inconsistent with any known comet. The surface polarization behaved like synthetic mesh. Even its incoming direction pointed near the region that had produced the WOW radio signal in 1977, a coincidence so eerie that older astronomers called it the echo of a forgotten greeting. But perhaps the most disquieting features were behavioral. The object's brightness fluctuated unpredictably, producing flashes of electric green light unconnected to solar heating. Its acceleration changed subtly, as though adjusting course, yet it displayed no visible recoil. It should have spun itself apart. Instead, it glided forward with eerie stability, silent and perfect. In isolation, any of these anomalies could be explained away. But together, they formed a pattern, one that hinted not just at mystery, but at method. Some called it coincidence, others called it control, and somewhere between those words, humanity realized it might be staring at something that remembered its purpose. Now, the countdown has begun. Between late November and January, every major observatory on Earth will turn toward ATLAS for what could be the defining astronomical campaign of the century. The critical night, December 19, 2025, marks the object's closest approach to the inner solar system. Across the Atacama Desert, the Canary Islands, Mauna Kea, and the Tibetan Plateau, domes will open in unison under frozen skies. Humanity will, for the first time, coordinate an interstellar experiment in real time. Inside NASA's Jet Propulsion Laboratory, engineers finalize a plan to bombard the object with radar pulses, while the James Webb Space Telescope prepares its instruments to capture high-resolution infrared spectra of the nucleus. The European Southern Observatory has tuned its spectrographs to detect non-thermal radiation, microwaves, gamma rays, or exotic emissions inconsistent with natural chemistry. Meanwhile, China's Tianwen-1 orbiter, positioned along Mars's orbit, will attempt to film Atlas as it glides past, stitching together frames that could reveal rotation or even structural detail. For a brief moment, global rivalry dissolves into unity. Every nation wants the same thing: truth. The goals are clear but monumental. Researchers hope to observe whether ATLAS releases an expanding coma of gas that would confirm natural sublimation, or whether its motion changes abruptly, hinting at propulsion. Any spectral fingerprint of nickel tetracarbonyl, unusual isotopic ratios, or gamma flares could shift the verdict from natural to artificial. Every data stream counts. Even a deviation of 1/10,000th of a degree could change history. In the days leading up to the event, observatories hum with quiet intensity, astronomers sleep in control rooms, journalists camp outside, and social media counts down in hours and seconds. Governments prepare statements for both outcomes: reassurance if ordinary, revelation if extraordinary. The world seems to hold its breath. Then, on the night itself, under the cold arch of December stars, the data begins to flow. Across screens from Pasadena to Beijing, a single thought unites billions of people watching a dot on a graph. Something from another star is here, and it is moving. The story of 3I/ATLAS is far from over. As the James Webb Telescope continues to stream its infrared portraits, the object glimmers like a silk thread in sunlight, its nucleus shimmering, its faint tail twisting under the breath of the solar wind. Gaia refines its coordinates each day. Hubble captures ultraviolet bursts as ionized gases peel from its skin. Every new dataset adds another stroke to the painting of a mystery that refuses to finish itself. What began as a faint blip in a Hawaiian survey has become a conversation between worlds. Through Atlas, we've learned that interstellar space is not empty. It is a highway of fragments, of wanderers carrying the chemistry of their birthplaces. This single visitor has already changed the calculus of planetary defense, inspired plans for intercept missions capable of catching future interstellar travelers, and reminded humanity that science works best when borders dissolve. Yet its most profound impact is psychological. For centuries, we looked outward, believing the stars were distant, separate, unreachable. Now, one of their emissaries drifts among us, answering our gravity, shimmering in our telescopes, rewriting the illusion of separation. Soon, as it nears perihelion, ATLAS will brighten enough to be seen even from cities, an interstellar spark tracing across the cold December sky. For those few nights, anyone who looks up will see not just a comet, but a messenger. And in that ghostly light, they may sense what astronomers feel every day: wonder balanced by responsibility. Because this is what progress truly looks like, not conquering the unknown, but bearing witness to it. The James Webb Telescope, built to glimpse the ancient past, has instead captured the present tense of the cosmos, a living experiment unfolding before our eyes. It reminds us that exploration isn't a choice. It's a reflex older than civilization itself. As Atlas sails outward again, reshaped by sunlight and gravity, it carries our gaze with it. Long after it fades beyond Neptune, the questions it leaves behind will endure. How many more wanderers drift unseen between the stars? What secrets sleep within their chemistry? And what will humanity become once we learn to follow them? Perhaps that is the final gift of this visitor. Not proof of life elsewhere, nor warning of catastrophe, but perspective. One fragment from another star reminding 8 billion minds that we too are travelers, circling our sun, crossing the darkness, searching for meaning in the endless night.